All right, so today we're going to be talking about Chapter 5, Lesson 5, Roots of Real Numbers. So what we're going to learn in this lesson today is how to simplify radicals and how to use a calculator to approximate a radical. So vocabulary, what is a square root? What is the nth root? And what is a principal root? So how do square roots apply to oceanography? So the speed s in knots of a wave can be estimated using the formula s equals 1.34 times the square root of L, where L is the length of the wave in feet. This is an example of an equation that contains a square root. So here's a diagram of what that might look like. So simplifying radicals. So finding the square root of a number and squaring a number are inverse operations. So when you take the root of something or square root and squaring something, inverse operations. To find the square root of a number, n, you must find the number whose square is n. For example, 7 is the square root of 49, since 7 squared is equal to 49. Since negative 7 squared equals 49 as well, negative 7 is also a square root of 49. So has two answers there, right? So if someone asks you what's the square root of 49, well, it could either be positive 7 or negative 7, right? Because positive 7 times positive 7 is 49, and negative 7 times negative 7 is also 49. So the definition of a square root is that for any real numbers a and b, if a squared equals b, then a is the square root of b, right? So similar, here's an example using numbers. If 5 squared equals 25, then obviously 5 is the square root of 25. Since finding the square root of a number and squaring a number are inverse operations of each other, it makes sense that the inverse of raising a number to the nth power is finding the nth root of a number. So the table below is going to show you how the relationship between raising a number to a power and taking the root of that number are connected. So for example, if I had a to the third power equals 125, well, I know that 5 times 5 times 5 equals 125. So that would tell me that 5 is the cube root of 125. Or if a to the fourth power equals 81, well, I know that 3 times 3 times 3 times 3 equals 81. So I know 3 is the fourth root of 81, right? Because 3 to the fourth power is 81. If I said a to the fifth power equals 32, well, I know that 2 times 2 times 2 times 2 times 2 equals 32. So 2 is the fifth root of 32. And finally, a to the nth power equals b. So a times a times a times itself n number of times is equal to b. Then I know that a is the nth root of b. So this is more of a generic form of explaining this. So this pattern suggests the following formal definition of the nth root. So the definition of an nth root is that for any real numbers a and b and any positive integer n, if a to the nth power equals b, then a is the nth root of b, right? So here's an example using numbers. If 2 to the fifth power equals 32, then 2 is the fifth root of 32. So the symbol, right, this is what's known as the radical symbol here. The nth root indicates, right, the nth root there. So this little number here tells you what root you're taking, and this is obviously telling you that you're taking a root. So here's an example, and here's a little tip of how you read this. If I were to read this, this would read as the nth root of 50, right? This is the root and what you're taking the root of 50, right? So the nth root of 50. And so just to break this down a little bit more, this is what is known as the index, right? The root that you're taking is known as the index there. This is known as the radical sign, right? This little almost looks like a check mark or a V. That's the radical sign. And the radicand is what you're taking the radical of, right? So the radicand in this situation would be 50. The index would be n, and obviously you have the radical sign there. So some numbers have more than one real nth root. For example, 36 has two square roots, positive 6 and negative 6, because both of those multiplied together, both of those squared would give you positive 36. When there is more than one real root, the non-negative root is called the principal root. So when no index is given, as in this one right here, the radical sign indicates the principal square root, right? So this is actually the second root of 36 right here. So the symbol nth root of b stands for the principal nth root of b. If n is odd and b is negative, there will be no non-negative root. In this case, the principal root is negative. So for example, the square root of 16 is equal to 4, right? Square root of 16 indicates the principal square root of 16. If I said the negative square root of 16, that equals negative 4, right? Negative square root of 16 indicates the opposite of the principal square root of 16. So in this scenario, the square root of 16 we know is equal to 4, but then obviously it becomes negative afterwards, right? So that would be the opposite, which would be negative 4. This is probably a newer symbol that you might not be used to reading. This means positive or negative. So the positive or negative principal root of 16 would be the positive or negative 4, right? Positive or negative square root of 16 indicates both square roots of 16, both being the positive and negative. If I have the cube root or third root of negative 125, that equals negative 5, right? The cube root of negative 125 indicates the principal cube root of negative 125 because negative 5 times negative 5 times negative 5 equals negative 125. This one only has one principal root and it happens to be negative. And then we have negative the fourth root of 81 equals negative 3. Again, negative fourth root of 81 indicates the opposite of the principal fourth root of 81. We know the fourth root of 81 is going to be 3, but this indicates the opposite. That's why we got negative 3 there. The chart below gives a summary of the real nth roots of a real number b. So this is the chart here. So if your index, right, your nth root is even, there will be one positive root or one negative root, right? So if I did the fourth root of 625, that could either work with positive 5 or negative 5, right? And that's only if the radicand, the thing I'm taking the root of, is positive, right? If it's negative, right, if I try to take the square root of negative 4, that is not a real number because no number squared is going to give me negative 4, right? I don't have anything times itself that would ever give me negative. So this one, in this scenario, would have no real roots. And if your index is odd, right, third root, fifth root, seventh root, you'll have one positive root if the number inside is positive, or if the radicand inside is negative, you'll have one negative root and no positive roots. And if your radicand is 0, it doesn't really matter what your index is, right? Any root of 0 is always going to be equal to 0. Let's look at an example. So here it's asking you to find the roots. We're given 4 problems here, so let's take a look at A here. We'll take a look at the first one. So if I look at here, it says plus or minus or positive or negative square root of 25x to the 4th. Well, I know that that is really just 5x squared. Well, what is the opposite? Remember, these are opposite operations, right? The square root and squaring something. So that's just going to give me positive or negative 5x squared. Another way you can think about it is the square root of 25 is 5, and the square root of x to the 4th is x squared. Again, positive or negative. We can see the principal roots there. So the square roots of 25x to the 4th are positive or negative 5x squared. Let's look at this one. Here I have negative square root of y squared plus 2 to the 8th power. Again, when I examine this problem, I can actually look at it as y squared plus 2 to the 4th power squared, right? Here I can see those opposite operations there. So when I simplify it, it really is just negative y squared plus 2 to the 4th power. The opposite of the principal square root of y squared plus 2 to the 8th power is negative y squared plus 2 to the 4th power. So here I have the third one that I'm going to look at. Now I'm looking at the 5th root. So again, when I look at this, I know that really it's 2x to the 3rd, y to the 4th to the 5th power, right? If I apply the 5th power there, it takes me to there. And again, just seeing that these are opposite operations of each other, right? 5th power, 5th root. So really it's just going to be 2x to the 3rd, y to the 4th. There it is in words. The principal 5th root of 32x to the 15th, y to the 20th is 2x to the 3rd, y to the 4th. Again, you could look at it as the 5th root of 32 is 2. The 5th root of x to the 15th is x to the 3rd. And the 5th root of y to the 20th is y to the 4th. So now as I look at the square root of negative 9, right, what is the square root of negative 9? Well, here I notice that this is an an even root, right, an even index, and it's a negative radicand, right? I'm taking the square root of a negative number. Well, that would indicate that the square root of negative 9 is not a real number, right? Nothing times itself, right? Nothing squared is ever going to equal negative 9. So therefore, this does not have a principal root. It's not a real number anyways. When you find the nth root of an even power and the result is an odd power, you must take the absolute value of the result to ensure the answer is non-negative. So for example, the square root of negative 5 squared is equal to the absolute value of negative 5, or just 5, right? The square root of negative 2 to the 6th power is equal to the absolute value of negative 2 to the 3rd power, or 8. If the result is an even power, or if you find the nth root of an odd power, there is no need to take the absolute value. And the main reason for this is because this needs to be negative in order for this to work, right? In order for that odd power to work, to give you that odd answer on the inside. If you use an even number here, a positive number here, you would not get a positive answer inside of the radical. So let's use simplifying using absolute values here. So here I'm simplifying the 8th root of x to the 8th. Well, note that x is the 8th root of x to the 8th. The index is even, right? So here's the even index. And the principal root is non-negative, right? So since x could be negative, you must take the absolute value of x to identify the principal root. So in this situation, since x to the 1st power is an odd root, right? I'm taking an even root, and I'm getting an odd exponent answer. It needs to be taken as the absolute value because it could be positive or negative. Same thing here, right? We have the 4th root of 81a plus 1 to the 12th, right? 4th root of 81 is going to be 3, and then the 4th root of a to the 1st, or sorry, a plus 1 to the 12th. So the index 4 is even, and the exponent is of 3 is odd, so we must use the absolute value, right? Because a plus 1 to the 3rd power, right? So when I do this, it'll be 3 absolute value of a plus 1 to the 3rd power. Obviously, we don't need to have the 3 inside of the absolute value because that is just an integer, so that is already positive, so we don't need it to be in the absolute value. So approximating radicals with a calculator, recall that real numbers that cannot be expressed as terminating or repeating decimals are irrational numbers. So for example, radical 2, or the square root of 2, and the square root of 3 are examples of irrational numbers. Decimal approximations for irrational numbers are often used in applications. So we all know that the square root of 1 is equal to 1, right? Because 1 is a perfect square. The square root of 4 we know is equal to 2, because again, 2 times 2 is 4. Square root of 9 is equal to 3, right? And so on and so forth, right? These are what are known as perfect squared numbers. So these are pretty easy to get because they give us whole number answers. But what they're explaining here is, well, what about when you have radical 2, or the square root of 2, right? we know that falls somewhere in between the square root of 1 and the square root of 4. So it's going to fall somewhere in between 1 and 2, right? And if you put it in your calculator, you will get out a decimal approximation because this decimal actually keeps going. It's irrational. It keeps going without terminating or repeating. So it actually keeps going. But usually your calculator will find a place to round it off. Same thing with the square root of 3, right? That falls somewhere in between the square root of 1 and square root of 4. It's probably going to be a little bit higher than the square root of 2, right? So if we approximate it with a calculator, it's going to be approximately 1.73. Again, the decimal keeps going. It doesn't repeat and it doesn't terminate, but your calculator will pick a decimal place to round it off at. So let's look at what this looks like in a problem. So let's approximate a square root. Time t in seconds that it takes a pendulum to make a complete swing back and forth is given by the formula t equals 2 pi times the square root of L over g, where L is the length of the pendulum in feet and g is the acceleration due to gravity, 32 feet per second squared. Find the value of t for a 3-foot long pendulum in a grandfather clock. So first, exploring, right, you're given the values of L and g and must find the value of t. Since the units of g are in feet per second squared, the units of time t should be seconds. So the plan is to substitute the values for L and g into the formula and then use a calculator to evaluate. So here is the formula. So I'm going to substitute my values L and g. Again, they tell me that L is 3, right, because it's 3 feet long, and g is 32 feet per second squared. So I'm going to put 32 in there. So I'm going to substitute my values in, and then I approximate that using a calculator. You can obviously put this in a calculator, and it'll give you something like 1.92, and it'll be a decimal that keeps going. It's an irrational number. It's a non-terminating, non-repeating decimal, but again, we're approximating and we're rounding it, so we're going to round it to 1.92. So it takes a pendulum about, right, approximately 1.92 seconds to complete a swing. So if it takes that amount of time, let's go ahead and examine it. Well, we know that the closest square root to 3 over 32 is simply 1 over 9, right? So, and I know 1/9, right? And pi is approximately 3, so the answer should be close to, again, if I put my approximate values in, right? I'm going to put 3 in there and put 1/9 in there, calculate it out. If you calculate it all out, it should give you 2. So the answer is pretty reasonable. We came up with 1.92. The approximate value should be somewhere around 2. So it looks to be approximately correct. So if you guys have any questions, please let me know. Thank you guys for watching.